My name is Ajla Aksamija. I'm a faculty member at UMass Amherst and also building technology researcher at Perkins and Will. So I'm going to be talking about innovations in architecture, engineering, construction, and the role of interdisciplinary research. Thank you, Gonzalez, for bringing really great topics. And I think this will be kind of a continuation of what you have been discussing. So the agenda for this talk, first we're going to talk about what is innovation, why is it important in our field, and what is the role of research. And then I will end with a few case studies from practice as well as from research side, just to sort of bring everything together and give you some examples. So majority of the presentation materials is coming from this book, Integrating Innovation in Architecture. I published this book probably almost 4 years ago. It came out first in the UK and then here in the United States. One interesting aspect is that during the research phase and writing of this book, I interviewed around 70 different firms around the world, extremely well-known, unknown, large scale, small scale, medium scale, to try to answer this question: what is innovation in our industry, and what are the appropriate steps to integrate innovation in our work? So I would like to offer this thought that innovation is a process of introducing meaningful changes to methods, services, or products. I would also like to offer this thought that there are different levels of innovation. Sometimes we tend to think of innovation as being kind of transformational and forever changing the way that we work, our practice, the outcomes of our work, but we can also have incremental changes and radical. So in terms of the product, this all relates to the building materials, systems, components, and so on. The services really relate to the practice, the way that we collaborate, the way that we interact with our clients. And then the process is really about the design process and delivery. And after conducting the interviews that I mentioned with various firms around the world, I realized that some of the main characteristics of innovative firms can be summarized here. They're really keen on the integration of design, different design methods, technology in their work, analysis, inquiry, really strong in terms of technical aptitude, and research-based design and process is extremely important. And then another aspect is communication and dissemination. In order to really change the future of our practice and our industry, we really have to be quite transparent about our research work, and sometimes maybe look at other disciplines besides architecture, engineering, and construction to really be open about the research and the impact of research on our profession. So integration of research into design process and practice is extremely, extremely important for innovative firms. I've also noticed, first of all, I would like to mention that in terms of the integration of research into architecture, engineering, construction, we are still in kind of infancy stages. I was the founding director of one of the first research labs in architectural profession back in 2008, Building Technology Laboratory, or Tech Lab at Perkins and Will, so 12 years ago. And at that time, there were very few firms that actually had active research departments. There were no established models. How do we integrate research into our processes? And I tried a couple of different aspects until I found a model that really worked. Press forward 12 years later, up until today, I would like to say that right now we have 3 different models for integrating research into our profession. The first is an internal model where the research and development team might be part of the firm, might be involved in the projects. The external model is basically a collaborative model where we have a firm collaborating with an external partner, R&D entity, and the R&D entity can be a university, research organization, And this particular model really works in terms of strong collaboration. And then the last model is a hybrid model, where there might be some connection between the R&D entity and design firm. So for example, I've seen over the last 5 years that many practices are opening up nonprofit arms that are dedicated to research, that tie into their projects, design practices, and so on, but are structured as separate entities. And obviously, there are some benefits to that model as well as drawbacks. Regardless, I think, as I mentioned, we're still in infancy stages, so it will take probably another decade or so to see which of these three models are the best. But hopefully we will be seeing more and more results of the research efforts and seeing what is the best methodology for integrating research into profession. I would also like to briefly talk about the economics and the financial aspects and the value of innovation. This is quite different in the profession compared to, for example, traditional research organizations such as academic institutions. So firms that are interested in conducting research or having active research departments, they initially need to invest funding into that work. So we have to kind of differentiate the aspects of the revenue and value. And for integrating research and tying in research to innovation, each organization that's conducting research needs to define what is the value of that work for the company. And I would like to argue, based on collected data and information about many different firms that are already doing this around the world, there's obviously direct benefit, doing better work, improving performance of projects. But there's also kind of indirect value for being leaders in innovation that sort of relate to setting the course of the future, trying out new things, experimenting. And obviously, we also have to tie in risk management procedures to innovation. But regardless, each firm that's interested in integrating research really has to define what is the value of that work. The last sort of theoretical aspect that I would like to mention before moving into examples and case study is what is the model for integrating innovation in architecture, engineering, and construction. So I would like to say that strong correlation between research and development, design, and investments is the way to integrate innovation in our work. And we have a couple of different aspects that are really important. Role of computation is really critical. Building information modeling and adopting new changes, integrating new materials, building systems, processes, new building technologies, as well as new construction techniques. But innovative firms, as I mentioned earlier, also need to invest into innovative culture and building innovative culture. And sometimes this also requires changing project delivery methods. And another really overarching aspect is doing collaborative work. So let's shift gears to the discussion of computation. So in terms of the advances in computational design and the relationship to innovation, over the last 10 or 15 years, something that I have seen is the role of parametric modeling, increased use of simulations and performance-based design, the paradigm shift of BIM as being a tool for design, collaboration, construction, fabrication, and facility management, and also integrated digital fabrication, robotic fabrication, and so on. Obviously, we have wide varieties of computational tools, interchange, collaboration, sharing information, modeling strategies is extremely important. And I strongly believe that we have also opportunities to develop new tools, new computational design techniques. In the next 10 years or so, I have to say that the trends that I see are definitely extension of BIM, integration of optimization techniques, integration of building performance simulations and modeling with the design process. So now I would just like to show you some examples of built projects, case studies that I find quite interesting and intriguing. So these case studies are actually coming from the book. So one of the great examples that I find quite interesting relating to the use of parametric design and modeling is the Louisiana State Museum of Sports Hall of Fame. Typically, when we talk about parametric design, we tend to think about crazy shapes, geometries, and so on that are sometimes even by the aesthetics. So this particular project from the exterior side looks very typical. So the rectangular box with shading devices, but parametric tools were really used in a smart way to develop the interior of the building. Because the building is a museum, the circulation of the building was very important, and you can see here a section through the building and a more detailed section, kind of the organic shapes, fluid movement and circulation. And I find it as one of the interesting case studies that sort of defy the idea of what is parametric design and its capabilities. Another project that I would like to mention is actually one of my research projects that's probably 9 years old now, where we try to integrate building performance analysis procedures, parametric modeling, and digital fabrication. And the purpose of the project was to investigate integration of these tools for a specific problem. And our problem was an existing building located in Chicago, which was built in early 1900s. And the purpose of the project was to reskin and reclad the project, basically to design a new building skin using these tools. So we tried different techniques at that time. In terms of the parametric modeling tools, we were still kind of in infancy stages, so we ended up building and developing some of the tools. But here you see basically the process where the procedure was based on doing building performance analysis to really understand solar radiation for different orientations of the building facades, using that data to drive the design decisions, to come up with parametric geometries and forms of the building facade, and then coupling that to different digital fabrication techniques. Advances in computational design and simulations are definitely changing our practice. So here you see a case study, one of the Perkins and Wills projects, and double skin facade system. Simulations were necessary for this project. Without doing computational photodynamic analysis, for example, it would be pretty difficult to design this innovative facade system. Robotic fabrication. This is a really interesting case study of a low-tech building. It's a vineyard. Robotic fabrication was used to fabricate basically modular brick facade system and to install. BIM is changing the way that we are collaborating, designing buildings, and so on. Here you see Louisiana State Museum Sports and Hall of Fame. You see different components of the BIM for the interior of the building, for all of the structural components, cladding, joints, surface support steel, and collaboration between the architects, engineers, and fabricators was really, really important for this project. Another interesting project where the coupling of BIM and fabrication was really key. Again, it's a very complex geometry, form, and shape. Here you see different components and elements of BIM model, and also fabrication methods. So BIM was used throughout the fabrication of this process, of this project, for all of the components, materials, but also to track the procedures. Now I will quickly go through some other case studies from practice and from research. Rush University Medical Center, located in Chicago. This was one of the first projects that integrated BIM during the design. So the design started in 2006, and the project was completed in 2012. Extremely complicated building shape and geometry, but I would like to focus on this special aspect, the entry pavilion, as the entry point into the building. We investigated a couple of different innovative strategies, and what was really key for this project is integrating simulations and modeling. There were so many aspects that were quantified during the design. Solar radiation, design of the double skin facade, solar exposure of different facade systems. Here you can see some building performance analysis simulations, basically looking into shadows and how much solar exposure are we going to have for this courtyard inside the building. This particular component was a really key aspect, a terrarium that brings nature to the lobby space. The question was, are we going to have enough daylight for any plantings and landscaping to work? So we conducted daylighting simulations to understand the quality of the daylight and the quantity of daylight. Extremely complicated shape and form of the terrarium. So you can see here during the design process, we used computational tools to determine the geometry and basically the final components. And here is the final image of the terrarium, the final image of the hospital. One of the other case studies that I will briefly talk about is smart facade systems, a current research project that we're working on that integrates thermoelectric materials into exterior walls. So these materials, based on the temperature gradient between the outside and inside, can be used to generate heating, cooling, or electricity. These are some initial concepts that we developed, but there are no tools to test this strategy. So we ended up doing an experimental study first to basically integrate these materials and figure out how or could they be used in facade systems. We used thermal chamber, thermal imaging to basically measure the heating and cooling outputs. The results were quite surprising. We also use computational photodynamics to determine the heating and cooling potentials of these new technologies. Right now, we're looking into integration of facade in real facade systems. Just some concluding remarks. We're really entering the era of unprecedented changes in our industry. New materials, building technologies, computational design methods, BIM, digital fabrication, all of these are influencing the way that we work and collaborate. But I would also like to point out that the integration of research is essential for innovative practices and for changing the future of our industry. The last thing that I would like to mention, I have a new book coming out early next year, Research Methods for the Architectural Profession, that actually talks about specific methodologies. And we're also initiating a new collaborative research entity at UMass Architectural Research Collaborative. If you have any questions or would like to find out more information, here's my contact information. Thank you.
Thanks, Ajla. Am I saying that right?
Ajla.
Ajla, okay, great. So that was a great presentation, covered a lot there. And so I do see a question. And so maybe we'll start with the audience question here. This asks, how does Perkins Will define, measure, and report the value and profitability of R&D? What are the success indicators? That's a great question.
Excellent question. I would like to say, I would like to first maybe offer a comment about the model that we found out that works really well. finding funding for research in our industry is extremely difficult. So during the early days of Building Technology Lab, I tried a couple of different things, and obviously firms have limited amounts of funding available for research. And something that I tried in the beginning was to tie in research projects to ongoing design projects, so that the research also becomes billable. That resulted in a model where approximately 50% of the research was directly driven by architectural projects, thus directly billable to architectural projects. So it became basically part of the services that we would offer to clients. And then the other 50% was research work, internally driven, internally funded, on topics that were really important for the firm, relating to new tools, processes, client engagement, materials, building technologies, and so on. So we developed kind of different metrics of tracking the value of these two different types of projects. Obviously, the first type, that's project-driven research, we would measure based on the outcomes. So the research was always driven by specific projects. The results would also be used on those projects as well. And some examples might be looking into innovative facade systems, or optimizing renewable energy systems for a project, or looking into application of new materials, for example. And then the non-project specific R&D, the value and the impacts would be measured on how exactly does it tie into the process, to collaboration. Are we using results? How exactly those results are being used? I would also like to point out that back in 2008, 2009, I decided to publish one of the first open access research publications coming from the practice. So I founded Perkins and Will Research Journal to be able to share the results of the research work conducted by the firm. And I can tell you that in the beginning, it was actually very hard to persuade corporate leadership, the legal team as well. Why should we share our research? So I was on this quest, coming from the research background and being a scientist. For me, sharing research results is extremely important. Sharing them in an objective manner and being transparent. So it took me probably about a year or so to get an approval to share this publication. So last year, we actually celebrated the 10th anniversary of the Perkins and Will Research Journal. And it's, as I mentioned, it's a transparent way to share the research results, which means that now those results are used not only by that specific firm, but other firms as well. We're able to track numbers of citations, the impact. So I would like to say there's definitely kind of the internal value, but I always argue for transparency of research work sharing, because that's the way to move the needle in our entire industry. So hopefully this answers the question, and I would be happy to talk more with whoever asked that particular question.
No, I think that was a great answer. I mean, it's hard, not in a dollars and cents way, but I think the fact that you're seeing gains in many other sort of instances within the firm and outside the industry is really what's telling. So sort of related to that, you mentioned about some of your R&D process, and we have a very similar process. What percentage would you say of your research, Perkins and Will's research, lies within, let's say, the incremental versus the radical versus the transformational?
Excellent question. So I would also like to point out that right now I'm only working part-time for Perkins and Will.
Okay.
7 years ago, I used to be a full-time practitioner, part-time academic for a very long time. And then 7 years ago, I made a switch. So now I'm actually professor at UMass Amherst and working part-time for Perkins and Will.
Yeah, my last question is going to be, how would you actually manage all of that, including writing
sure,
books? So
sure, I'll
a little bit. Okay.
I'll get to that. But in terms of the incremental, radical, transformational, It's hard to give specific percentage, but I would have to say that the project-specific research works tend to be incremental or radical because we're typically focusing on a specific design problem, on a specific project, specific questions, then we select research methods and so on. We do share the results. The direct benefit are for that particular project, and obviously the lessons learned can be applied to others. But I would say those tend to be, so project-specific research tends to be incremental or radical. On the other hand, more general and broad R&D that deals more with the processes, development of new tools, new procedures, that tends to be radical or transformational. Because it has a broader impact to many different projects, many disciplines, and so on. Something else that I would like to point out, especially differences between academic and practice-based research, is the time frame, and obviously budget as well, funding, but time frame. In practice, we actually don't have a lot of time for research, especially for project-based research, because design teams, engineering teams, they cannot wait 6 months or a year and a half to get some results to proceed with the design process. So that means that research in practice that's driven by specific projects tends to be very short. Right. So that's why, you know, it cannot really be transformational, because those tend to be short-term studies. Long-term studies tend to be these that forever change the way of our practice. And then you had a question about differences between academia and profession.
I was going to get to that. Because, you know, you do have this sort of dual role as an academic as well as a practitioner, as well as, you know, leading some innovation and R&D in the firm. Given what you've seen over the last, you know, dozen years or so in practice, what would you recommend, let's just say, for the architect out there that's about to enter, or the university, we're about to enter the market?
Yes, great question. This notion of integration into practice is relatively new. And I think for future of our profession, and especially for raising the bar and for innovative firms, it's extremely important that we are trained also to think not only as designers, engineers, contractors, but also as researchers in a way, and to integrate research into our work. So for younger professionals that might be entering school or entering profession, my recommendation would be to experiment as much as possible, to really learn about what is research, how does it integrate with the design process, what are the appropriate strategies as well. Because although we have been moving the needle, you know, over the last 10 or 15 years, I strongly believe that we have so much more improvements in the future. So over the next decade or the next 20 years, I definitely see our profession changing, our industry changing, and research becoming an integral part of what we do and what we have to offer. Because it has to do, it deals also with kind of the outcomes of our work. We influence built environment so much. We have so much impact with our profession on the society, on the future, on building performance, on climate change, and so on. At the same time, we also have so many challenges that are currently facing us. Directly pandemic, but also indirectly economic aspects, you know, social aspects, and so on. So I think that we are definitely entering this era of change, and for young professionals, I really recommend getting training in what is innovation, how do you integrate research into your work, being able to experiment, and the role of creativity also becomes extremely important, but that's another discussion.
So, what I thought was interesting about your project presentations was the aspect of computation. And, you know, the things that you mentioned, parametric modeling, simulations, BIM, digital fabrications, you know, I would say didn't exist 20 years ago, right? So the conventional architectural firm that was very good at doing architecture 20 years ago probably is not the same looking firm today, right? And so what do you see as the future? Maybe it's kind of relating to the last question I asked. There's a lot more to do, right? It's a lot more complicated of a problem. We didn't have the tools to do simulations 20 years ago. Now we do. And everyone's struggling to figure out what, you know, how to do all this effectively and efficiently.
Exactly, exactly. And these are all just tools, and it's more about the process. And maybe I can offer you a bit of background information about me and how did I end up where I am today, and how did I even become interested in research and so on. So in mid 1990s, oh my God, that was so long ago. Yes, but basically my background was I finished undergraduate studies in architecture. I finished a master's in architecture. I practiced for a while, and then I realized that there were, like in mid 90s, I realized that there were all of these questions in profession that I didn't know how to answer. And I also in mid 90s ended up working for a firm that used ArchiCAD as the first BIM tool. Before that, I had no idea what BIM was either. Like, I was like trained as a traditional architect. So being introduced to one of the first BIM tools forever changed my kind of thinking and philosophy. And then I became more interested in research. And I started asking all of these questions. How can we create new tools that improve our process? Like, what is the role of computation in the design process? But this was really, really early on. And then I decided to go into research. And then basically I had to go outside of architecture into other disciplines, engineering, computer science, mechanical engineering, and so on, to learn about all of these processes, a bit about computer science, about engineering, to be able to answer all these questions. So, and then again, this was like mid 1990s, and that somehow really shaped the rest of my career and who I am today. So my point is, tools change, the processes change, but this notion of research and always trying to do better should be the underlying kind of objective for everything that we do. I think in the future, some of the trends that I'm seeing, definitely creating tools that improve our design process, improve collaboration, but in an effective way. So being able, for example, to use the same model that we're using for the design, to use that same model to do simulations and modeling, to send that information to fabricators. I think that's the future. Also being able to do optimization as well. I haven't really talked about the role of optimization in coupling with the building performance simulations, but that's something also that I see in the next decade or so, a growing area of our work. So the tools are going to change. They will continue to be improved, but it's all about the process and staying curious and always trying new things that really ties to the innovation.
So I totally agree. So we do have a question from the audience. The question is, what's the relationship between your scope of project-related research and the research conducted by project team members? Are there distinct scopes of responsibility?
Great question. It depends on a project by project, and really depends on the expertise and specialty. Something also that I would like to mention, that at one point, I would say in early 2000s, I realized that I cannot be involved in all of the projects, and I started training project teams to do some research work. So besides me doing specialized research, depending on the scope of work, research questions, and so on, I also worked on training project teams that may not have previous training in research and how to conduct research and so on, and basically to make it a bit easier for me, but also to implement research on a wide variety of projects. So that meant training people to use, for example, simulation tools and modeling, developing training material for integrating research into design process. And that made it a bit easier for me. And that also resulted in better integration of research on a project-by-project basis. So that we might have a champion, for example, in each office who's kind of responsible for leading research efforts. And then they can certainly ask me questions. But I found that to be a successful methodology in terms of sharing the work and having sort of a broader impact on a variety of projects.
So that also sort of gets to my next question of dissemination. Like, how do you take that research, whether it's on projects or on a regular R&D sort of specific project, disseminate that to the rest of the firm, especially if the firm is large as Perkins as well?
Exactly, excellent question. So writing research reports, writing articles, presenting. So obviously there are two ways of disseminating and sharing knowledge, internal and external. And I never made distinction between internal or external sharing.
And you got in trouble for that?
Not really. I think in the beginning, yes, because people could not really understand, like, why do we need to share all of our research? And again, because I was trained as a researcher, for me, that's like a given. It needs to be peer reviewed. It needs to be shared with the community, and so on. So reports would be written. Reports would be shared with all of the offices. Presentations would be organized to share internally. But then majority of the work was shared externally as well. So Perkins and Mill Research Journal, it's still open access. If anybody goes to our website, they can find this publication. So I think in the last 12 years, we published more than 200 articles. And by the way, Perkins and Mill Research Journal is peer reviewed. So all of the work that's submitted gets peer reviewed by external reviewers, not by internal people.
So lastly, what would you recommend to a lot of firms out there? And I get this question quite a bit: is how do I start my own R&D, computational sort of group within the firm, and convince sort of the executives of the firm to make some minimal investments, just let's say, to get something going?
Exactly, excellent question. I think the first step is to determine what are the objectives of this research group, what types of projects they will be dealing with, addressing, and so on, because research can be quite broad, but it can also be specific as well. So determining the scope for the research group. In terms of convincing the leadership, the corporate leadership, and so on, defining value for research, and then defining the value of innovation as well. And again, this highly depends on the internal culture of the firm, values, and so on, but defining what is this value. And the value can be direct benefit to projects, improvement to projects, better design process, or it can also be kind of this implicit value, just being better in what we do. But again, this is very specific for each firm. And then determining how much funding is necessary, what type of people, what type of research expertise is necessary to do those projects, and then also developing a strategic plan. I think that's really, really important. And my suggestion for firms that are interested in integrating research is to develop a 5-year strategic plan with short-term goals and long-term goals. So, and obviously some of these can be flexible and can be kind of reviewed on an annual basis, but without having clear sets of objectives and strategies, it's very hard to be successful. And then another suggestion is maybe to start with smaller, so determine, you know, the scope of the work, identify specific projects, and then find the right model. We talked about integration of research using 3 different models. Is the internal the best way,
Yeah.
or maybe collaborating with external partners, pairing up with an academic institution? That's also very, for some, I would say, smaller firms and medium-sized firms, that might be a better way to go rather than having an internal research department.
So we have 2 questions from the chat and from the Q&A that if you can touch on quickly is, one is, what is the role of architectural education in shaping AEC innovation, and how can it be better tied to practice? That's one. The other is, do you think something like the European research scheme, like H2020, which I'm not familiar with, is needed in the United States?
So let me start with the first question. In terms of the education and the future of practice, we really need to train future architects, engineers, what is research, how to actually execute research studies. And I have been teaching some courses. I have been also teaching workshops for practitioners as well that are interested in tying in research to design processes as well. So obviously, you know, doing better training and education. And then in terms of the European model, yes, I am familiar with different European models, especially relating to facade systems, because that's sort of a research topic that's dear to me. I would say, yes, we need something like that in the US. The only problem is that the research funding mechanisms in European Union and in the US are completely different in terms of publicly funded, you know, governmental projects and so on. And I would say that in European Union, a lot more, like the larger percentage of governmental funding has been invested into architecture, engineering, and our industry. In the US, historically, unfortunately, not a lot of funding has been invested into research relating to the built environment. And that's also one of the problems and one of the issues that needs to change in the next 10 years or so. But it can only happen if, again, we are transparent about our research. We show to people who might be outside of our field the benefits and how important it is what we are doing to society at large. And then hopefully that will result in more research funding, federal research funding being available to research that deals with the built environment.
Well, thanks, Ajla. That was a great presentation and great Q&A.
That was awesome.
Appreciate it. Thank you.
Thank
You're
you
welcome.
so much.
You're welcome.
That was
Bye.
great.
Thank you. And if anybody has any follow-up questions, feel free to always reach out to me.